We will learn about the marginal rate of technical substitution and how it is calculated. The question is, for the production function Q, which is a function of two inputs, labor and capital, which is equal to 300 times L raised power 1 upon 3 times K raised power 2 upon 3, we have to find out the marginal rate of technical substitution between labor and capital. Okay, so let us first be familiar with the marginal rate of technical substitution. So marginal rate of technical substitution is actually, it shows us the rate, and let me write it here. So it shows us the rate at which one factor must be decreased to maintain same level of output when another input is increased. Okay, so it is being given by marginal rate of technical substitution shows us the rate at which one factor must be decreased to maintain the same level of output when the another input is increased. Okay, so the marginal rate of, if I write it here, so marginal rate of technical substitution, let us say between labor and capital, is equal to the marginal product of labor upon marginal product of capital, which is equal to minus times change in capital upon change in labor. Okay, so let me explain it on the graph, then we will solve the question. Okay, let us say we have labor on the horizontal axis, capital on the vertical axis. Let us draw an isocount. Okay, let us say this is the isocount. By isocount, what we mean, isocount shows us the different combinations of capital and labor which produce same level of output. Okay, let us say this isocount shows us the output level of, let us say, 10 units. Okay, so let me explain it here. Let us say the change in capital is 3 units and the change in labor is 2 units. Okay, that means del K is 3 and del L is 2. What does this mean? It shows that to move from this point to this point, okay, we need to increase 2 units of capital, okay, and sacrifice 3 units. Sorry, we need to increase 2 units of labor and sacrifice 3 units of capital to maintain same level of output, that is 10, or to produce same level of output, which is 10. Okay, and similarly, if we have, let us say here, we have 2 units of labor, 2 units of capital and 1 unit of labor. So here del K is 2 and del L is 1. So from this point to this point, what is the marginal rate of technical substitution? It shows us that when we increase 1 unit of labor, we have to decrease 2 units of capital to maintain same output level of 10 units. Okay, so on this curve, the marginal rate of technical substitution varies along the curve. Okay, if we have a straight line, okay, let us say if we have labor on the horizontal axis, capital on the vertical axis, if our isocount is a straight line like this, we will have, that is, let me show it here, let us say here we have 1 and 1, Here also we have 1 and 1. Okay, so when we have this kind of, when the inputs are perfect substitutes, marginal rate of technical substitution is constant. That means if we increase 1 unit of labor, we need to decrease 1 unit of capital to maintain same level of output. Okay, and this marginal rate of technical substitution is actually the ratio of the marginal product of labor and capital, which is in fact the slope of the isocount. Okay, the slope of the isocount, like this, like this. So on this curve it will vary, the slope will vary, and we always take, rather at times we take the absolute. We know that there is the, when we substitute one factor for another, that means we will have the negative slope in this case. Now coming to the question, or let me explain it further. That means marginal rate of technical substitution shows us how many units of capital has to be reduced or decreased, okay, in order to maintain same level of output, so that we increase 1 unit of labor. Okay, simple thing. How many units of labor we need to increase to maintain the same level of output? Okay, in comparison, okay, I am getting confused, sorry. So it simply shows us how many units of capital we should increase in comparison to the decrease in the units of capital, so as to maintain the same level of what we call the output. Okay, I hope I have done justice in the definition part. Now let's calculate the marginal rate of technical substitution. So first we need to calculate the marginal product of labor then. So marginal product of labor is simply the change in the output due to the change in the units of labor employed. That is the partial derivative of this production function with respect to labor. Okay, so if I partially differentiate this, the exponent of L will become coefficient. So we have 1 upon 3, then we have this 300, and exponent of L is subtracted by 1, so 1 upon 3 minus 1, it becomes minus 2 upon 3, and k raised power 2 upon 3 will remain same. Similarly, marginal product of capital shows us the change in the output due to the change in the units of capital employed, the partial derivative of the production function with respect to capital this time. Okay, so the exponent of the capital or k will become coefficient, so we have 2 upon 3, then we have 300, L will remain same because we are taking partials with respect to k, and the exponent of k will be subtracted by 1, so we have 2 upon 3 minus 1, so this is 2 minus 3, which is minus 1 upon 3. Okay, now we know that MRTS is the ratio of marginal product of labor upon marginal product of capital. Okay, to save the space, let us divide it here like this. Okay, what will happen? 300 gets cancelled, or if I write it here, so first we have 1 upon 3. If I transpose it to the numerator, it becomes 3 upon 2. Okay, here let us transpose this L to the denominator. It will get multiplied with this L. Okay, but the sign of the exponent will change. And similarly we have k here. Let me write first the k raised power 2 upon 3. If I transpose this k, it will get multiplied, but its exponent will change from minus 1 upon 3 to plus 1 upon 3. And similarly we have L raised power 1 upon 3. If I transpose this L to denominator, it will get multiplied, but exponent sign will change from negative to positive. So simple law of the radicals. So we have plus 2 upon 3, 2 upon 3. So 3 and 3 gets cancelled. We are left with 1 upon 2 when the bases are same, we can add up the exponent. So 2 upon 3 plus 1 upon 3, let us write it here. It becomes 2 upon 3 plus 1 upon 3. And for capital, or let me write it here like this. Here we have 1 upon 3 plus 2 upon 3 because bases are same. So it sums up to be 1 upon 2 k upon L. So this is the marginal rate of technical substitution between labor and capital. Okay. So we can see here that if I write it here, so del K upon del L, as I have told you, it came out to be K upon 2L. So what exactly does it tell us? Del K upon del L shows us, or it shows the amount of capital that can be the amount of capital that can be reduced when labor is increased. Okay. Amount of capital that is required to be, that is required to be, that is required to be what? Okay, sorry, let me put it another way. It shows us the amount of capital that we need to decrease, okay, when the labor is increased. And it came out to be K upon 2L. This is the marginal rate of technical substitution between labor and capital in this question. I hope I make myself clear in this video. Thank you.